All right, this video is going to teach us the last of our 3 strategies for solving quadratic equations, and that is the quadratic formula. So unlike the last 2 strategies, both of which had some instances where they didn't work, like the zero product property can only find rational roots, and completing the square, I've only taught you to do it for when a equals 1. The amazing thing about the quadratic formula is that it always works. So the problem, of course, is that it doesn't always work easily, but it will always work. So it's kind of your option of last resort. So to use the quadratic formula, you have to start off with an equation in y equals ax squared plus bx plus c form, or standard form. And then what this formula tells us is that if we're trying to find the roots, or if we're trying to find when x equals 0, then whenever y equals 0, and you take your a value, your b value, and your c value, if you plug them into this big, magnificent, glorious formula, it will give you the answer for x. Now, this hopefully looks a little bit familiar, because you've actually been doing stuff like this from your homework for the last couple weeks. That's why I've been assigning those crazy order of operations problems to get us kind of ready for this video. You might be wondering where this formula came from, but don't worry, we'll get a chance to look at that later this week. All right, so let's see what this is all about. So if I wanted to find the roots of this quadratic here, and I tried factoring, but I couldn't figure it out, and it's got a 2 in front of the x squared, I don't want to complete the square, then I might try the quadratic formula. So I can see here that in this equation, my a value is 2, and my b value is -3, because it's a minus 3x, and my c value is a -5. So I'm going to start by just writing out the original formula. You should do this a few times. You want to get really used to it. So x equals -b plus or minus the square root of b squared minus 4 times a times c, and the square root needs to go over all that, all over 2a. Now I'm going to replace in my a value, my b value, and my c value. So I'll rewrite it. So instead of writing -b, I'm going to write -3. Then plus or minus the square root of -3 squared, and then minus 4 times a is 2, and c is -5. All that over 2 times 2, because a is 2. And then you do what you've been doing in the homework, so you simplify. So I know some people were still struggling with that, so I am going to show all the steps to make sure we're doing it right. So we do x equals -3 is just 3. That's the opposite of -3. Plus or minus the square root of -3 squared is 9. And then minus 4 times 2. That gives me, I'm going to switch colors here. The 4 times 2 would give me 8. And then the 8 times -5. That looks like it's a positive 40. I want to see what I did there. I did all 3 multiplication steps in once, although you could have broken it up into 2. All that is over 4, because 2 times 2 is 4. So x equals 3 plus or minus the square root of 49 divided by 4. And so now I break it into 2, just like with completing the square. So one of them is x equals 3 plus the square root of 49, which is 7, divided by 2. The other one is x equals 3 minus 7, divided by 4. And that, of course, is because we have this plus or minus here, which should just feel familiar from the completing the square solving that we do. And so this one gives me 10/4, and this one gives me -4/4. So I have 2.5 or -1. So x equals 2.5, or -1. Now the fact that this did end up with nice numbers means that it actually was factorable, and I just couldn't figure it out. But that's okay. All right, next time I go through one, I'm probably going to do it a little bit faster. So if you got lost in that explanation, maybe go back and rewatch one more time before you move on to the next one. All right, so here's our next example. Take a moment and try and decide, what does A equal? What does B equal? What does C equal? Be careful. Did you say that C equals -13? If so, you made a mistake, because we have this -10 over here, and the quadratic formula only works when it equals 0. So our very first step is we need to make it equal 0. So we're going to add 10 to both sides. So that'll give us 2m squared minus 7m minus 3 equals 0. And we can fill in our a, b, and c. So a is 2, b is -7, and c is -3. I encourage you to write out what your a, b, and c are, especially in the beginning. It just really helps to have them to look at when you're plugging them into this big, crazy, ugly formula. Okay, so I'd like you to pause now and plug those numbers in. Write out exactly what you think the quadratic formula is going to look like before you start simplifying, to make sure that you get that part right. All right, so let's do our formula now. So at this point, I'm kind of singing the song in my head. I'm doing x equals -b, so -7, plus or minus the square root of b squared minus 4ac all over 2a, like that. And then I do my order of operations. I'm going to do them kind of quick. All right, so now when I get to this point, square root of 73, that is definitely not a square number. And so that means that these roots are going to be irrational. It's going to have irrational roots. So from this point, I have a choice. If I want to give the exact roots, then I have two of them. They are 7 plus the square root of 73 over 4 and 7 minus the square root of 73 over 4. If I want roots that are more useful, that give me a better sense of where these numbers might actually be, then I'm going to grab a calculator or the graphing calculator option in Desmos, or not the graphing calculator, but just the calculator option in Desmos, and I'm going to type them in. So my calculator tells me that the square root of 73 is approximately 8.5. So then I can use that to find my decimal equivalents. So I get about 3.9 for the first one and about -0.4 for the second one. So if we were in class, I would mostly be asking you to give me exact roots. Since we're having to type these answers into Google Forms and things, I'm probably going to be doing a lot of the decimal equivalents for you guys this year. All right, so you've seen this twice now. I want you to pause and see if you can work these two out for yourself. I'm warning you right now, these ones end up a little bit differently than the earlier ones do, okay? But the same formula applies. So go ahead and pause, take a couple minutes, do the quadratic formula on both these examples, please. Okay, so for the first one, we need to rewrite it so that it equals 0. So to do that, I'm going to subtract 6a, and I'm going to add 3 to both sides. I guess I could have just subtracted the 3a squared. It won't make any difference in the end which way you do it. So 3a squared minus 6a plus 3 equals 0. Then I'm going to write down what my a, b, and c are, and then I plug into the formula. So out of habit, I've just been writing x equals each time. Since the variable in here is a, I really should be writing a equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now at this point, so we did negative 6 squared and got 36, and then we did 4 times 3, that's 12, times 3 is 36, so minus 36. At this point, you should be looking at this and saying, whoa, that's interesting, 36 minus 36. That means we're going to get a equals 6 plus or minus the square root of 0 divided by 6. Well, the square root of 0 is just 0. There's no positive or negative about it. We remember that from our completing the square work. So that means there's only going to be one answer to this. The answer is going to be 6 over 6, or 1. So only one root. So this is one of those parabolas, if it were a parabola, where it has a vertex just at the 1. We can tell, because our a value was positive, that this guy would be pointing up. All right, let's do the next one. So here it's already set up equal to 0, thank you. And we have a equals 3 again. This time, what is b? There is no number there, but we know how to deal with that. We've dealt with that in class before. That's just a negative 1. And then c equals 10. Let's plug them in. Double check that your initial expression looked right. Now, you guys know that I do like to skip steps, right? Like I don't write out every single step super meticulously every single time, but writing it out the first time, just totally exactly the way it's supposed to be, is really, really important. Don't start skipping steps until later, okay? Make sure you get that first step totally written out. So then we do our simplifying. And over 6. Now here, for me, another red alert is going off, because right here, that is going to end up negative. And we know that that's a problem where square roots are involved. So this one, we get x equals 1 plus or minus the square root of negative 119 divided by 6. Yuck. At that point, we say no solution. In a later class, you're going to learn that that these are imaginary numbers. We've talked about that, and so you would say that there's imaginary roots. We're not doing that. We're just saying there's no solution. Once you end up with a square root of a negative, you are off the hook. You are done. You just need to have proved your work up to that point. All right, so far, hopefully you've noticed that if this number under here ends up being positive, then you're going to get 2 answers. If that number ends up being 0, then you're going to get 1 answer. If that number ends up being negative, you're going to get no answers. This piece underneath the square root, the b squared minus 4ac, has a special name. It is called the discriminant, because it allows you to tell the difference between different types of quadratics without having to solve all the way. So the discriminant equals b squared minus 4ac, and it allows you to see how many answers there's going to be to the quadratic. We, of course, have another way to tell how many answers there are. That's if you're dealing with a perfect square, or if you're dealing with something in completed the square form. So if you had 3 times x minus 4 squared, and that equaled, once you get it to this point, and that equals, negative 4, well, if that number is, once again, if it's negative, that means that there's no answers. If it's positive, that means that there's 2 answers. If it's 0, that means that there's 1 answer. And we know that because after we divide by the 3, which isn't going to change the sign, the next step is going to be to take a square root. And square root of a negative is just not going to work. All right, go ahead and find the x-intercepts of this parabola. I want you to do it by using the quadratic formula. It is possible to do this one by completing the square, but I haven't taught you how, and I want you to practice using the quadratic formula. You're going to round to the nearest tenth, but in your notes, please keep the exact roots as well so that you can reference that.